just to preface, we're piloting a new textbook. Okay, so there's that. Also, I'm using new technology just to try it out and see what happens. So with that being said, please bear with me. It's gonna be a little messy sometimes. That's okay. We're just gonna rock with it. Okay, so on this first one, what's gonna happen is it says, and you're gonna want to follow along because I know it's backwards on my end. It says, what would the graph of the function look like for band B with the fan base growing twice as fast as band A's fan base? So if I were doing from fan base A to B, and we're doubling, then that's going to look like this equation. So we see how the initial is 100 times 3 raised to the x. Yep, that really is backwards. Okay. Then what's going to happen is we're going to have 100 times 6 raised to the x. Going to die. It's from the media center. But this has been happening all day where it's just dropping the
mine doesn't
connector.
at least 3 times.
About to just like go paper pencil unlike this. Like so done. Mm-hmm. Yeah. Sure, visual. Let's see if I can flip this. Oh, here we go. Boom, fix it. Right, averted. Now we can see. All right, so now compare and contrast these two. So are our bases the same? Are our bases the same? 3 versus 6. Are they the same? No. So the bases are different. But our initial is the same. So bases are different. Initial is the same. Now, suppose band C starts with a fan base of 200 that is growing twice as fast as band A's. Compare and contrast this new function with the previous two functions. So for band C, we're going to have 200 and we're going to multiply it times 6 and we're going to raise it to the x power. Yeah. Bases are different. Okay, so I need to get smaller exponent. On C, it's 200 times 6 raised to the x. 5 point. That's what's going to happen. So from this one, which is C of x, at A of x was initial 100, right? So A of x was initially 100. So C of x is 200. So our initials are different. With B of x, we had the same rate, but different initials, initial value. So on the next one, it says, how does the graph 2 to the x plus 1 compare to the 2 to the x? Okay, so on this one, 2 to the x is our parent function. I think of this as like my OG, my original gangster. Yes. Okay. Over here, we've got 2 to the x plus 1. If you don't remember, last time we had this conversation, we talked about this. And this is actually written a little bit better over there on my board, so that way you can see it. This is talking about the different transformations. So what's going to happen is that plus 1 is going to go up 1 compared to the parent function. Okay, Nico, what was your question, babe?
I was asked.
Okay. Cool. All right, on the next one. So how does the graph compare to the parent function? So again, this guy's a parent. And so how is that similar? How is that different? We've got a -1 out there. So what is that going to do to the function?
Go down.
Go down 1. Everybody understand? Everybody okay? Okay. On the next one, it says compare the graph 2 to the x. What effect does h have on the graph? Okay. So coming down here, we have 2 to the x plus 2. We have 2 to the x plus 2. Okay. So compared to 2 to the x, 2 to the x is our OG or our parent function. So this guy's our parent. Okay. And then we have this 2 to the x plus 2. So this is going to be left 2. Why did I say left and not right? Because it's plus 2. Okay. In our original formula, in the exponent, it's x minus h. So it's like the opposite of what you normally would think. Okay. Can you try the next one? Okay. So I feel like y'all figured this one out. What did y'all get? Okay. Right. 2. Good. Perfect. Okay. With the parent function, you always want to identify what that looks like. And that's always going to be like your most like basic thing. Like there's no plus whatevers. It's just a number raised to x. Okay, that's always going to be your parent function. Okay, let's go ahead and take a look at the next page. Oh, yes. All right, so it says, and I'm going to work on this. It's going to be great. Okay, so it says the graph of function b is a vertical translation of a graph and has a y-intercept of 0. How does the graph 3 to the x plus 1 compare the graph of b? So how does the graph compare?
It goes to the right or
Is that left one?
the right word.
Is it in that exponent? It's not in the exponent. So it's not going to be left or right.
It's gonna go up.
It's going to go up. Okay. But let's look at this description again. It says a vertical translation of the graph 3 to the x. So we got 3 to the x. This guy is the parent, right? Has a y-intercept of 0. How does that compare to c of x?
It's a wire stuff.
This now has a y-intercept of 1. Good. Okay. So this is going to have a y-intercept of 1. Okay. They also talk about another vertical translation. So they talk about this b function. So b of x would have 3 to the x plus k. They didn't tell us what the vertical translation was. They just said there was a vertical translation. So this would be either up or down k units. Because in this description, they said there's a function b that has a vertical translation of this graph. Would be plus or minus k. Yeah. Yeah, I know it's a little tricky. Go ahead and look at b. It says, how does the graph 3 to the x minus 3 compare to the graph of 3 to the x plus 4? This one's a little tricky because we miss out on some stuff on this one. So coming down here, looking at b, I'm going from this one to this one. So from -3 to 4, how much did I move? 7, right? Okay, so it's not just up 4. We're comparing this function to this function. So we're going from -3 to 4, and that's 7 units up. Does everybody see how I got that one? So it's different from what we've been doing previously. Previously, we've been going, hey, it's up 4. This one, we're comparing from this to this. Okay, cool? Okay. What's wrong? Confusion. What? That's basically it. Now, it might be a little bit more advanced. It might have like a number that goes out front, or it might have like an exponent, like +7 in the exponent. That might change things a little bit, but right now this is just going from -3 as a y-intercept to up to 4. So how many units is that? 7. Okay, go ahead and flip the page. All right, I want you on this page, I want you to do all of the even numbers. Everybody knows what an even number is? That's 2, 4, 6, 8, 10, 12, and then 14. Okay, don't do the odds. Don't worry about it. Okay, but I want you to do the even number problems, and then we're going to go over them in just a second. I need you to attempt these problems. When I send progress report and I get the question of why is my baby failing, or why is my kid not getting the grade that they need to, I'm going to tell your parent to look at this book. And if your book is blank, that's going to be on you. Okay, so please, 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 when I give you time to practice in this textbook, let's do it. Okay, so on number 2, it says, how is the effect of k on the graph a raised to the x plus k similar to the effect of h of the graph of a to the x minus h? How is it different? This question will come up on your final because it looks like it's confusing, but it's not. So when we talk about k, what does that do to our graph? It moves it, right, it moves it up or down. Now, when we talk about h, what does that do? Left, right. So that's how they're different, right? Okay, so k goes up or down, and then h goes left, right. So how they're similar is they have the same initial. Good. Another thing that they're similar to is that h and k are still moving the graph. So h and k move the graph, but they have the same initial. So I said move graph, initial value same, and h moves it left to right, and k moves it up and down. Okay. And I promise I'll get better about this zooming in. So again, move graph, initial value is the same, k value moves up or down, h value moves left, right. Okay. All right. On 4, it says, as the value of k switches from positive to negative, what is the effect of the graph? So as we move k from positive to negative, what does that do? For k? It goes down. Okay. So as we move negative, moves down. Okay. Don't forget, tomorrow we have mastery check over this kind of stuff. So please be paying attention. Okay. All right. Looking at number 6. I'm going to jump up here. All right. Compared to the parent function, what's happening? 2 to the x plus 1. What does that give me? So compared to that parent, this is the parent. What's the difference? Okay, adding 1. So what does that do to our function? Moves up 1. Now you could have graphed this. That's okay. I'm not going to sit here and graph it for you. Joyce, can you turn on that other light? I'm going to see if this is just because it's dark in here. You can graph it in Desmos. Is that better? No. Can you flip the other light? Is that better? No. Okay, put it back. Never mind. Okay. So on the next one, we've got -4. So what does that do to it? Down 4. Okay. So again, we're looking at number 8. Looking at number 8. So it's down 4. So it's down 4. Okay. On, yes. Yeah, I don't have one today, but I'm gonna bring it tomorrow. That's the idea. Okay, on number 10, it says compare the function represented by this graph. Okay, and represented by the table. So we're comparing table to graph. Those are two separate problems. Remember, when we do exponential functions, this is the formula. We've got a times b raised to the x, where a is your initial, and then b is your rate. So a is our initial. What's our initial amount here? 2. So we have 2 times. How do we find our b? How do we find our rate? Not the difference. We're close. We're going to find that ratio. So really quick, we're going to take 2 and divide it by 1.5. 2 divided by 1.5. And that gives us 1.3. Well, we got to make sure that that works for everything, right? Well, it doesn't though, right? Like if we check all the other ones, it doesn't work. So we can't really figure out what the ratio is yet. What if we graph this one? What if we graphed it? So let's take this and let's plug it into Desmos. Let's go here. And let's go into Desmos and let's graph it. And look at what I get. Okay, so here's my table in the purple, and here's my function in the red. Okay, from this dot to this dot, what happened? So from 0, -2 to 0, 2, what happened? Not up 2, up 4. So we moved up 4. Okay, so back on our paper, we're going to say move up 4. Okay. Now, if we would have taken the red equation and we would have added 4 to it, what would that have given us? So we take this red equation and added 4, what would that give us? So -3 plus 4 is that the function right there? Yeah. So on that table, our equation is actually 2 raised to the x plus 1. And it moved up 4. Yeah. Okay. I need to bring a link. Yeah. Love it. We love to see it. Okay. All right. On number 12, what do you see? It goes to the right one. Good. What about 14? It goes down 1. Okay. So 12, we're going to the right one. 14 goes down 1. Questions on that? We okay? Okay. Mastery check over this stuff tomorrow. Go ahead and see if you could go back into learning.amplify. Let's see if that Wi-Fi kind of reset. Go in, you're going to go to the one that's called bank accounts. I don't know how to say this person's name. Mauricio? Yeah. Has to invest $500 to invest. Has $500 to invest. Try to see what the value of account A is over time. So what's happening each time? We're adding 50, right? Adding 50 each time. Okay. All right, looking at number 2, we're going to see if this account does something else. All right, so what's happening each time on this line? We're adding 25 what? All Are we adding 25 each time?
No.
No, we're probably multiplying by some rate, right? Okay. Well, how do we figure out what that rate looks like? Well, we can divide the second term divided by the first term, and that might help us. Okay. Let's look at slide number 3. So here is the work shown. So we were actually multiplying by a rate of 1.05 to get the next one. Which account would you recommend him to invest? Say it again. The 51, account A? Yeah, why? It makes more money. Boom. Okay, on slide 4, we're going to use the simple interest formula to help us solve. Okay, so we know that he invested 500 initially. We learned that the simple interest formula looks something like this, where A was your initial. So what's my initial amount? All right, and then what's my rate? We have 1 plus 0.10 raised to the t. Can you figure out when t is 5, what is y going to be? All right, so what did y'all say it was? All right. And that is correct. All right, on slide 5, we're dealing with compound interest. So if you forgot the compound interest formula, it's over there on the board. But it's P times 1 plus R divided by N raised to the NT. All right, so this is happening 5% per year. So our initial was 500. Then we had 1 plus 0.05 raised to the 1 times T. And then I want you to plug in 5 and tell me what you get. So you plug this into your calculator and you plug 5 in for T. What did you get? You got 6 like a decimal.
No, it's like, I got 638.14.
There you go. All right, 638.41. Is that what you said?
No, 1/4.
1/4. Okay. Da-da-da. Got it. Cool. All right. Moving to the next one. How are these two things alike? And then how are they different? Very similar, but still giving us a different result. So take a moment. Tell me how they're similar. How are they different? Okay, once you finish that, go ahead and go to slide 7. Oh, you're working on slide 6, 7, and 8. You're going to discuss with a partner, and then we're going to talk about it in just a second. So you're doing 6, 7, and 8 and discussing with a partner. So click on the arrows on the graph to watch the accounts balance grow. Yes, you may. So discuss with a partner, which account would you recommend? Mauricio? I don't Mauricio, whatever. Okay. Which one would you recommend?
The simple interest one.
The simple interest, why? Yeah, but in
long term.
in 30 years, he'd make more with the compound interest, right? But with the simple interest, he's making more on the initial amount. So it's kind of like, how long do you want this to go on, right? Like if I was 50 years old, I would want simple interest. If I was 10 or 20, probably compound, right? All right, Mauricio decided to invest in an account that offers 6% compound interest per year. He wonders when the balance will grow to 1,000. About how long will this take? How did you go about solving this one? So you just kept substituting in? Okay, let me show you a shortcut. Because on the next slide, it shows this. So this is what you probably did. You plugged in 500, you multiplied it times the rate, and then you plugged in 9, you plugged in 10, you were trying to see how much that was. That takes forever. Over here, if we type the equation in, like the original, and then we type in y equals 1000, what we can do is we can see where it crosses over and it tells us that x value. Like you zoom out, they're making it real complicated, but you zoom out and then you can see where it crosses. Agreed. Come on. I said this was faster. Be faster. I probably should have sped it up. It's okay. And then look, so on this graph, we have this line. It's whatever that x value is. So that's 11.896. And that's the exact time that that would happen. Everybody understand? Okay, so try on number 10 to do that. Use Desmos on this one. Okay, take a moment. You're trying. So about how many years will it take for the balance to hit 2,500? Which 23. Yeah. Boom. Is that what you got? Yes. Okay. All right. Let's go ahead and skip to slide 12. Okay. How do the investments grow with simple interest? How do they grow with compound interest? Okay. So remember, you're using those formulas. Okay. And you can go through those tabs and you're telling me the difference. Okay. All right. Once you get slide 12, you're going to do 13. Okay. Please make sure that you are completing those. Okay. Again, when your parents come and ask me, hey, why is my baby failing? Or why is my baby not having an A? I'm going to be like, here's their Desmos activity that we did on this. Here's their workbook. If those things are blank, that's not my fault. Okay. I say this is like a review, but it is. It kind of like sums up everything that we've been talking about recently. Yeah, it hits just about everything. So the last like 2 slides are a little tricky, and we're gonna go over that more, but this tells me where are you at this point right now. Okay. So please make sure that you take it seriously because it does give me feedback. Okay. Just a couple reminders. Once you get this done, you're gonna work on your review guide. For homework, I want you to finish 5B. So that's that second page inside, and it's talking about the transformation. So it's this page to this page. It's not super long, but it practices for our mastery check. Okay, so if you don't have the review guide, it's right here. So again, for homework or after you finish this quiz, I want you to do 5B. Okay, and that's talking about the transformation section. Okay, if you want to do the entire review guide, great, because remember your test is on Friday. Okay, your test is on Friday, and you have to have your review guide done in order to take your test. So I'm trying to help you. Go ahead and get one section done because we just finished learning about it. Okay.